So in this video, we are going to study the working of DAC0808, digital to analog converter, the reverse operation of ADC. The difference is in ADC, we are giving digital data and getting analog signal. Sorry, in ADC, we are giving analog signal and getting digital data. The analog signal we are going to give is voltage, whereas in DAC0808, the analog signal we are getting is the current. Okay, so the digital to analog converter, it is a device which is widely used for converting digital pulses to analog signals. There are two methods, R to R ladder and uh, binary weighted resistors. So we are using R to R ladder method. So the resolution is a function which the binary input we are giving. That means 8 bit, 10 bit, 12 bit, like that. So the resolution for DAC0808 is 8 bit. Okay. So in which form the output is available? Output is available in the form of current. Okay. So output current will be decided by the status of bits you are giving. This D0 to D7 is the digital data we are giving. Basing on the status of these bits, this output will change. This I reference is also in our control. What is the resistance we are connecting it to? VCC. VCC by reference will give the reference current. Okay. So output pin is connected to a resistor. So to get the voltage, what we need to do in general, we need to pass that current through a resistor. But if you follow that procedure, there may be a chance of loading effect of the resistance we are connecting. So we need to create an isolation between the output of the DAC and the measuring voltage. So this can be achieved by using an op amp. So the reference, the output current is applied to the op amp with a feedback resistance of 5 kilo ohms. Okay. So this is the pin diagram of DAC, where it requires the output current is available at pin number 4, I0 or I0. Okay. The data which we are going to give 8 bits, A1, A2, A3, A4, A5, A6, A7. And the supply required for the IC, VCC, ground. And V reference plus, V reference minus, and it requires a negative supply, VEE, which is the drawback of this IC. In addition to the power supply, it requires a VEE, negative power supply. Okay. One is NC, no connection, and 16 is compensation pin. We need to connect a capacitor to stabilize the operation, to stabilize the voltage. So different pins: 1 no connection, 2 ground, VE negative power supply, IO output signal, 5 to 12 A1 to A8 MSB and LSB bits of the digital data which we are giving, VCC positive supply, V4 reference plus, reference minus. We said I reference na. So for generating that I reference, how much voltage we are giving? It is to be between 14 and 15 pins, and the resistance we are connecting there. So compensation pin, we will connect a capacitor to it. So this is the DAC pin, the data which we want to give between 5 to 12. The output is available at pin number 4, and the output voltage is isolated from the output of DAC using an op amp, and the inverting terminal is connected to output, non-inverting terminal is connected to ground. In feedback, we will connect 5 kilo ohms. Power supply 5 volts, VCC, and the other is ground. And V reference, in general, it will be 10 volts. V reference VEE, we said na, negative power supply, it is given as minus 15 volts, and V reference plus is this, V reference minus will connect to ground. Okay. So these are the connections. So whenever you connect ADC like this, then if you give any digital input here, this current will change according to the digital input you are giving. And this current is converted to voltage using this current to voltage converter. This is the operation of DAC0808. Okay. So if you want to generate any, if sine wave is required, so we will calculate what is the voltage for sine 0, how much voltage is there, for sine 30, how much voltage is there, for sine 60, how much voltage. So we will decide the voltages at different phase angles. So we will give input to the DAC one after the other. So for DAC, to get an output voltage of 5, the digital input we need to give is 128. To get 7.5 volts, digital input required is 192. Okay. So 8 bits kadandi. So for 8 bits, maximum value is 255. So sine value, maximum value is 1. When sine value is 1, it is 255. Since negative voltages are not possible, for 0 we are giving 128. Okay. So for minus 1, we are giving 0. That means, just a minute. Suppose this is sine wave. Just a minute. See, this is sine wave. So since it is not possible to generate negative values, what we are making, the minimum value, we are making it equal to 0. So sine negative maximum value, we are making it equal to 0. Okay. So that's why sine 0 is 128, sine minus 1 is 0. Okay. 255 lo half. Okay. That is 128. So while writing code, so you'll place all the values. Sine 0 antandi, sine 0 is 128. For sine 30 degrees, 192. So sine 0, sine 30, sine 60, sine 90, like that. What are the digital equivalents we are placing in an array? We are giving input to the DAC one after the other. So first sine 0, sine 30, sine 60. Digital outputs are available. Okay. Digital outputs are available at DAC pin number 4. So till now, whatever programs we are observing, the output we are observing in the microcontrollers. But here, our microcontroller will not give any output. We are giving input to the DAC using microcontroller. The output is available at DAC IC. Okay. We need to observe the output in the CRO. Okay. This is the output that we are able to see in the DAC pin number 4. A pin number 4 దగ్గర కరెంట్ వస్తుంది. After the op amp, this is the output we are going to get. Okay. Thank you.